Good morning, class. This is the beginning of our college algebra review. If you notice, we will not be covering formulas from geometry. We will, however, be covering R.2, integer exponents, polynomial expressions, factoring polynomials, rational expressions, radical notation, and rational exponents. And radical expressions. I will be skipping through a handful of things and, just covering the important parts. Excuse me. For teaching example 1, you can see here that for we're writing things in exponential expression, and for example A here, the solution is 10 to the minus 2. So let's take a look at that. Notice it's asking you for the exponential expression with the base of 10. So notice this base here is 10. So we're going to call it b equals 10. All right, and then how did we get to this number right here? Well, it's the base of 10 is like saying 1 over 10 times 1 over 10, and that is giving us this 1 over 100. And so the exponent is whatever it is to give you your original function. This is just another way to write your answer. And so these numbers are pretty simple, like b of 164. Let me give this some space here. The number 64 with a base of 4. So again, your b is going to be 4, and we need to find here you need to find what x is. Okay, so 4 to the what power is going to give us 64. And so you can see here 4 to the third power gives us 64. And that is 4 times 4 times 4. And finally, for this last problem, the number 125 with a base of 5. So again, your base is 5. I'm going to write it up here, the exponential expression, where this is your base and this x is your exponent. And this is like saying 5 times 5 times 5. Now I want you to notice something. For a here, the number is, we're going to call the number m. It is less than 1 but greater than 0. And that causes your x to be negative. And notice these numbers, c and b, we'll call this, those numbers m's, they're greater than 1. And notice that your x is positive. And now that is a rule to remember. Okay, if you have a number that's less than 1, you typically have, if you have an exponent that's less than 1, you typically have a number that's less than 1, as well as a x that is negative. Okay, now if you have a number that's greater than 1, like b or c, you're going to have an exponent that's positive. Now these are simple numbers. Typically you write things in exponential notation when you're dealing with millions, billions, trillions, and even larger numbers. All right, so let's evaluate each of these expressions. Again, this should be a review for you. If it is not a review, and this is something you are learning for the first time, I really suggest you doing a lot of practice problems because you're going to be using all of these sort of skills in the college algebra to do more difficult problems. Okay, so these are just skills and tools that you need to get through this course. So evaluating this expression, this is 5 to the negative 2. So if you remember, this number is going to be less than 1 because our exponent is negative. Now, before I continue on, notice all of these exponents are negative. Okay. And it doesn't mean that your value is negative or your number is negative. So this number here for A, 5 to the minus 2, just means that it is a number less than 1. It doesn't mean you have a negative number. So we're going to do A up here. And so this is like saying 1 over 5 to the positive 2, just like this. Okay, if you have a negative exponent, you can flip it down and get the, it's called the reciprocal, right? Oops, sorry. The reciprocal, okay? And so this is what 5 to the negative 2 really looks like, 1 over 5 squared. And that is like saying 1 over 5 times 1 over 5, and that gives you 1 over 25, right? So your first answer is 1 over 25. Notice that if you take the reciprocal of 5 to the negative 2, you have 1 over 5 squared. Let's take a look at this next problem. Notice that this is on the bottom and it's also negative. We typically want to get rid of negative exponents. And so this really looks like 4 squared. And that's actually an easy number, right? 4 squared, that's just 16. See? So the key thing here is, why are they making it more difficult? They just want you to practice using negative exponents and taking the reciprocal of it. Now notice this one here for C. Notice you don't have 1/3, right? 1 over 3. Here you had 1 over 4 minus 4 to the minus 2. The reciprocal of 2/3 is just going to be, if you flip it over, okay? 3/2 to the 5th power. Okay, make sure everything is in parentheses. All right, 3/2 to the 5th power is, notice, 3 times 3 times 3 times 3 times 3, and I think, I can't remember if I said 5 3s, times 3, right? So 243 over 32, okay? The next problem, notice here we have 3x to the minus 2. Notice the 3 and the x are in parentheses. If you had, say, for example, 1 over x to the minus 2, okay, only x to the minus 2 is included in that minus 2, okay? But because there's parentheses around this whole thing, you need to flip up the whole 3x, and now it is 3x squared. And that's easy, right? You can go 3 squared and x squared, and that's just 9x squared. If you're having any trouble with these, or you're not quite sure, you know, how I'm getting this, again, we are just taking the reciprocal, and the reciprocal, I keep touching this reciprocal, it's hard to write with this. Say, for example, you had x, right? The reciprocal is just 1 over x. If you had, let's say, 1 over 4, the reciprocal is just 4. If you had 10, the reciprocal is 1 over 10. And last but not least, something like this, let's say 4/5. The reciprocal is 5/4. So again, just flipping it over. So this last one here, notice they have 4 to the negative 1. And notice here, 2x to the minus 2, there's no parentheses around the 2x, so it's only x to the minus 2, not 2x to the minus 2. Okay, and so notice this 4 goes on the bottom and just makes it 4. The 2 stays where it's at. Okay, notice that the 2 is staying where it's at, and this x to the minus 2 comes on top to become x squared. And so this is x squared over 2 times 4, which is 8. Okay, so again, this is the product rule. Now, for the product rule, the rule goes like this. If you are multiplying base of, let's call this x, times the same base, and let's call it y, all right, then you have base to the x plus y. Notice the base stays the same. Oops, that looks like a 4. X plus y. And you're only adding the exponents. Okay, you're not multiplying the exponents. There will be a case for multiplying the exponents, but that is another slide. All right, so if that's the case, notice the base is the same. This is 6, and this is 6. So this becomes 6 to the minus 4 plus 2. And minus 4 plus 2 is 6 to the minus 2. And this becomes 1 over 6 squared. And this becomes 1 over 36. Okay? Now, I think that's what you get right here. All right. Now for part B, I'm just going to go ahead and write it out. This probably looks neater than me trying to write it. Notice the base is all the same, x, x, x. So we have x to the minus 2 plus 5 minus 6. So minus 2 plus 5 is plus 3. Plus 3 minus 6 is minus 3. And so again, we have x to the minus 3. You want to take the reciprocal. It's 1 over x cubed. And last but not least, notice, for example, that this whole thing is in parentheses. So you got to, this is a little bit different. So you think, oh, it's not the same. No, the bases are the same. Okay, but you need to multiply 5 times 6, which gives us 30. And now we have x to the minus 3 plus 4, which is just minus 3 plus 4 is 1, and so you have 30x. Okay, you can say to the first power, but that's not necessary. All right, so again, the quotient rule. Okay, again, we're talking about exponents and expressions with exponents. In this case, the quotient rule is if you have a base with x and the same base, and it's as a fraction right here, you have the base stays the same, x minus y. So if you're multiplying, you add. If you're dividing, you're going to subtract the exponents. And so you can see for this first problem, 10 to the third power over 10 to the seventh power. And so you have 10, keep the base the same, 3 minus 7, which is minus 4. And again, you take the reciprocal. This gives us 1 over 10 to the fourth power, or 1 over 10,000. For this problem, this is y to the 7 minus 3. Can you guess what that is? Yeah, 7 minus 3 is just 4. So again, all of these sort of basic adding and subtracting concepts, you just have to know the rules for exponents, and it's actually quite simple. And that's as simplified as it gets. Now this last problem looks a little complicated, right? So we're going to do everything in parts. Okay, so 6, oh, oops, I didn't do that right. Okay, so this is 6. 6 divided by 12, right, is 1/2, right? 1 over 2. X to the third power over x to the sixth power is x to the 3 minus 6. And then this is y, notice right here, to the 2 minus 1. Okay, and so they write all of that here for you, but this is why they do it. We do each part separate. Okay, and so it's simplified as to 1/2 x to the third power times y. If we want to get rid of that negative exponent, you bring the x down here with the 2. All right, raising power to the power. Now, this is the case where if you have some base to an exponent, and you want to take the exponent of an exponent, in this case, you have b to the x times y. So if you're taking the exponent of an exponent, here you can multiply exponents. And so this case is just, this first case right here is 6 to the 3 times 2, which is 6 to the 6th power, and that is just a really big number, 46,656. Now notice this is negative, And those rules still apply. A negative times a positive is a, yes, a negative. And so this is 2 to the negative 2 times 3, which is 2 to the negative 6, which is right here. And again, you can get rid of that negative exponent, and it's 1 over 64. This last one is x to the 3 times minus 4. So again, notice your exponent is negative, but this is as simple as it goes. Take the reciprocal of it, 1 over x to the 12th power. All right, so raising product powers. What happens if you have more than one thing inside the parentheses? The previous one was, oh, you have, let's say, for example, x squared to the 6th power, right? Where you're like, well, that's simple. You multiply those, and that's just x to the 12th power. All right, well, what if you have both of them? Well, you you actually take the exponent of both of them. And so this becomes x to the 4th power, y to the 4th power. Okay? You're going to take 3 to the minus 3 in part B, and x to the 3rd power to the negative 3rd power. Okay, so x to the negative, 3 to the negative 3 power, which is 1 over 3 squared, right? I mean 3 cubed, sorry. And x to the 3 times minus 3, which is really x to the minus 9. And again, we're getting rid of those negative exponents. So everything is on the bottom. So it's 1 over 27 x to the 9th power. I am going to be marking you. You want to simplify as best as you can. I would prefer you leave things in fractions as opposed to maybe using your calculator and finding some sort of decimal solution. And the last problem here, notice there's 3 things. There's a 2, there's an a squared, and there's b to the minus 1. You're going to distribute this negative 2 exponent to every single term. So 2 to the minus 2 power is actually 1 over 4. A to the 2 times minus 2 power, which is a to the negative 4 power, and this becomes a to the 4th power as the denominator. And this last one, minus 1 times minus 2, that's just b squared, and so that stays on top. And so this is your most simplified answer. So the key here for all of these problems is you must simplify. Okay, big key here. All right. Raising quotients to the power rule. So other one we were, notice we were multiplying. And so again, you're going to distribute this exponent to both the numerator and the denominator. And so in this case, this is like saying 4 squared over b squared, right? And so what does that look like? Notice it's the same, 16 over b squared. And again, for this problem, part B, so you take 2 to the minus 2 power and b to the 4 times minus 2. So notice that they're still multiplying these across, okay? We're just keeping the exponent. So 2 to the minus 2, let's get rid of that negative exponent. So we bring it on the numerator. And this becomes b to the minus 8. So again, the minus is on the bottom, so we're going to bring this on top. We're going to flip everything around. And so this simplifies to b to the 8th power divided by 4. Now this problem looks pretty complicated. Notice there are 3 terms, 2 on the numerator and 1 on the denominator. Every single one gets the minus 3 exponent. So 4 to the minus 3. Notice it comes down here to the denominator to become a 4 to the positive 3 power. X to the minus 4 times minus 3 is really x to the 12th power. And minus times a minus is positive, right? And then again, y to the minus 3 power, we're going to make this positive. And so notice it ends up here. And so once we simplify that, you have x to the 12th power, y to the 3rd power, and then 4 to the 3rd power is 64. All right, so again, simplifying some more expressions. I know this is taking a little bit of time, but I really want to make sure I go over all of them. There's one more slide after this. And so here, notice we have 4 terms. We're going to do x to the third to the minus 3 power, y to the minus 2 times the minus 3 power, 2 to the minus 3 power, and z to the minus 3 power. Okay, so let's do all of that. Notice we flipped this around, right, and brought this to the bottom. Okay, and then notice this is a trick. This is minus 3, right? And so we're going to take the reciprocal of everything inside here. So this goes on top and this goes on bottom. Now, if you didn't want to do that, okay, you don't have to. You could say, let's take it up here, x to the 3 minus 3, right? And 2 to the minus 3, z to the minus 3, and y to the 2 times minus 3. You could do that, okay? But notice you have all these minuses, so you're just going to flip everything over anyway. So this kind of saves you a step. But notice all of this right here is on top. So 2 to the third power is 8. Z to the third power is just z to the third power. And y to the 2 times 3 is y to the 6. And the last, the denominator, I'm sorry, is x to the 3 minus 3. Notice it's in order of exponents from largest to the smallest. All right, and another problem. Again, a to the third power times b, all of this whole thing to the minus 2 power, and a times b to the 4th power, all to the minus 3 power. So let's get rid of these negatives. And so notice this comes on the bottom, right, and this comes up top. So again, a trick. If you have a negative exponent, flip whatever you have inside and take the reciprocal. And so this is easy, right? A to the 3rd power is just a to the 3rd power. And b to the 4th power times the 3rd power right here is b to the 12th power. And again, this is a cubed times 2. This is a to the 6th power. Okay? And then you have b to this b squared. Okay? And so again, you need to simplify this. This is not completed. So remember the quotient rule. This becomes a to the 3 minus 6, right? Which is a to the minus 3 power over, or times, 12 minus 2, which is b to the 10th power. So again, this is a to the minus 3 times b to the 10th power, and so this just becomes b to the 10th power over a cubed. Okay. I don't think you can, it's the same thing there, but I don't think you can see it because the video here is blocking it.